Lesson 2A, Ion Formation. Here are the board diagrams of the first 20 elements that you were responsible for drawing last day. Remember the trends that we looked at in class? They were the addition of a single proton as we move left to right and downward on the periodic table. We also noticed that all the elements in the first column have a single valence shell electron. The second column has 2, and so on until you reach the end when the valence shells are completely filled. We also observed that as we moved down the periodic table, more shells were filled. The first row was a shell of 2 electrons, the K shell. The second row was a shell of 8 electrons, the L shell. And finally, the third row contains up to 8 electrons, which is the M shell. Let's look at the Lewis dot diagrams of the atoms, which only show the valence shell electrons. Our last lesson on families of the periodic table, remember the last column was called the noble gases, since they do not react with any other common element. They are noble. You can also see that they have complete valence shells. The complete valence shell is what makes an atom stable. So all of these other elements are more reactive than the noble gases because they have incomplete valence shells. Looking at sodium, which is an alkaline metal, it has a single valence shell electron, as with all alkaline metals. Its incomplete valence shell makes it extremely reactive. Losing an electron completes its valence shell, similar to that of a noble gas. This is why the element sodium will easily give away an electron to become a positive 1 charged ion. This is true of all alkaline metals. Elemental sodium is a soft gray metal that is toxic, volatile, and corrosive. In this video, you will see that it's so reactive that it immediately oxidizes in air and will auto-ignite in water. In fact, it's so reactive that we don't find elemental sodium in nature. We have to refine it from other compounds and then store it in non-reactive oil. This is what ionic sodium looks like when combined with chlorine ions and mixed with water. It is a white crystalline solid that is stable and safe to eat. It's also known as table salt. Ions often do not share the same characteristics that we find when it's in elemental form. If we have a complete shell, they will be more stable than elemental form. Stable means that they will not decompose or break down or react with other elements well. Elemental atoms with fewer electrons to gain or lose to complete their valence shell will react much stronger to lose or gain those few electrons. That is why alkaline metals with 1 electron to give away and halogens with 1 electron to gain to complete their valence shells are so reactive. These elements lose or gain electrons more easily. Looking at the elemental families we're responsible for in grade 10, the alkaline metals all have 1 valence shell electron. Rather than gain 7 electrons, they will lose that 1 electron to become a charge of positive 1. The alkaline earth metals all have 2 valence shell electrons and will lose 2 electrons to complete their valence shells to become +2 ions. The halogens at the other side of the periodic table are all missing 1 electron, so rather than giving 7 away, they will gain 1 electron to become a -1 ion. The noble gases all have complete valence shells. They will not gain or lose electrons, and they tend to never form ions. They are naturally stable. As you can see on your student periodic table, the alkali metals would all like to give away an electron to become positive ions. The alkaline earth metals would like to give away 2 electrons to form +2 ions. And moving to column number 5, we can see that they would love to gain 3 electrons to complete their valence shells, becoming -3 ions. The next column over will gain 2 electrons to become -2 ions. And the halogens, who are missing 1 valence shell electron, would love to gain 1 electron to become -1 ions. The noble gases at the right of each row have complete valence shells, and they rarely gain a charge from losing or gaining electrons.